Let's talk about sequences. A sequence is a set of numbers called terms that are arranged in some particular order. The first term we note is called a sub 1. A sub 2 would be your second term, a sub 3 the third term, and so on. And we call the nth term a sub n. So those are some terminology that we use when we're talking about sequences. We have two main types of sequences that we're interested in, arithmetic and geometric. If it's arithmetic, it will increase or decrease at a constant rate, and you can notice that because it's adding or subtracting between each term by the same amount, and we call that a common difference. If it's geometric, it will increase or decrease at a common ratio. So it will go up by multiplying, or it could go down by multiplying by a fraction. So let's look at some examples right here. This one is going to be arithmetic, so let's see what happens. So you look at the first compared to the second, and one way you can do this is say a2 minus a1 to figure out the common difference. So a sub 2 is 4 minus a sub 1, which is 2, will give us a common difference of 2. You want to make sure that the same pattern would apply between each term before you decide that this is arithmetic. So for instance, a sub 3 minus a sub 2 would be 6 minus 4, which is also 2. So we would say D equals 2. It has a common difference of a positive 2 because it's increasing, it's positive, and then it's increasing by 2. And then we can think about when we learned about our now next equations, we would say now, so the term we have now plus 2 would equal the next term. So that's how it would look in a now next format. And so it also, we need to point out that it started with 2. That is our a sub 1, because the first term is usually very important with some formulas we're going to learn about later. So let's look at a geometric sequence over here. So we're looking for a common ratio. It's going to be either multiplying or dividing between each term. So a2 minus a1 is a good way to figure out what's happening. So we could check 4 minus 2 would be 2. And then a sub 3 minus a sub 2 would be 8 minus 4, which would be 4. But notice those don't have a common difference. So that's what makes this one geometric, or neither but not arithmetic. So we can rule out the fact that that would be arithmetic when it does not have the same common difference between the second and first term and the third and second term. So let's back up. Since I'm limited on space, I'm just going to erase that. But in your notes, you could leave it and add this underneath it. We could say a sub 2 divided by a sub 1 would be 4 divided by 2, which is still 2, but that's just a coincidence. And then we could do a sub 3 divided by a sub 2 to make sure it would have the same ratio of 2. So a sub 3 is 8 divided by a sub 2, which is 4. And we still have a 2. So this would work as a geometric sequence, and your common ratio would be 2. Technically it's 2 over 1, but we don't have to write the 1 as our denominator. For the now next equation, we could say that now, whatever term we have now, times 2 would equal the next term. And a sub 1, or your starting value, was 2. Because that's usually an important thing they ask you about. So let's look at some more examples. So for example 1, we have 3, 9, 15, and 21. So we could use the same steps we were just looking at. Like we could say a sub 2 minus a sub 1 would be 9 minus 3, which would be 6. So we're checking to see, is this arithmetic? And then we could say a sub 3 minus a sub 2 would be 15 minus 9, which is also 6. So it wouldn't be bad to just double check. 21 minus 15 is also 6. So your common difference would be D, would equal 6. And it's positive because we're increasing between each term. You could say that your term you have now plus 6 would give you the next term. So that would be your now next equation. And your a sub 1, or your start value of your sequence, was equal to 3. That's whatever they give you first. So let's look at example 2. We have 6, 48, 384, and 3072. Definitely looks like they're increasing in some format. So we could say a sub 2 minus a sub 1 would be 48 minus 6, which would be 42. And a sub 3 minus a sub 2 would be 384 minus 48, which would give us 336, but we could tell just by looking at that, it's not going to equal 42, so it's not arithmetic. So let's check geometric. So we do a sub 2 divided by a sub 1 would be 48 divided by 6, which would be 8, or technically 8 over 1. And then we could do a sub 3 divided by a sub 2, which is 384 divided by 48, and that would also equal 8. So it is a geometric sequence, and it has a common ratio of 8. So let's write in our notes. This one was arithmetic. So it'll stand out nicely when you're looking back at your notes. It's a good example of an arithmetic sequence, and this one ended up as a good example of a geometric sequence because it's increasing by multiplying, where this one was increasing by adding. So ratio was 8. Our now next equation would look like now, whatever you have now, times 8 would give you the next term. And a sub 1, or your starting value, was 6. All right, so let's look at a few more. So number 1, we have 3, 8, 13, 18, 23, and so on. So what we could do is, instead of writing all those steps, you can use your mental math to help you figure this out, and then we can go from there. So let's look at 3 to 8. How would we go from 3 to 8? So you might think first that we could add 5. So let's check and see if that would work throughout this sequence. So if we add 5 again, would we get 13? Yes. And if we add 5 again, we would get 18. And if we add 5 again, we would get 23. So this one is arithmetic, but you don't necessarily have to write all those steps. Those steps help when you especially have some weird numbers that are harder to look at than these. So let's say that this is arithmetic. Write that down in your notes. That we have a common difference d of a positive 5, so it's an increasing sequence. And our now next equation would be now plus 5 equals next. And our a sub 1 value, or our starting value, was equal to 3. And again, we point that out because they ask us questions about that sometimes. So let's look at number 2. 1, 2, 4, 8, 16. So this one is getting bigger. It's important to also notice quickly, is it increasing or decreasing? Because sometimes that can eliminate some answer choices if you're considering things. So 1 to 2, I could either add 1 or I could multiply by 2. But then 2 to 4, I can't add 1 to go from 2 to 4. So we cancel out that possibility. But I could multiply by 2. So from 1 to 2, I can multiply by 2. To 2 to 4, I can multiply by 2. To go from 4 to 8, we can keep multiplying by 2. So the multiplying by 2 works for this sequence, which makes it a geometric sequence. We have a common ratio, r, that's equal to 2. We have now times 2 would equal next. And we have a sub 1 is equal to 1. So that's your starting value. So let's look at a few more. We have 24, 12, 6, and 3. So this one is going down or decreasing. But is it decreasing by subtraction or by dividing? Because those are the two ways it could decrease. And if it's inconsistently decreasing, we'd say it's neither arithmetic or geometric. So to go from 24 to 12, we could subtract 12. But to go from 12 to 6, you can't subtract 12 again. So let's say, what if I go from 24 to 12 by dividing by 2 or multiplying by 1/2? So like half of 24 is 12. Would that work here? Is half of 12 equal to 6? Yes. And then half of 6 is equal to 3. So that ratio fits our sequence. So we would say this one is geometric. It has a ratio of 1/2. We could say now times 1/2 equals next. And a sub 1 was equal to 24. So that's lots of good information we could gather. And depending on the question they ask, you might not need all of those things. It's just good to point them all out for our examples to put into our notes. So let's look at number 4. We have 55, 51, 47, and 43. So we could look and see if we could, because these numbers would not be kind if we divided. Let's say 55 to 51, we could subtract 4. Can we subtract 4 to go from 51 to 47? Yes, that would work. And then 47 to 43, you could also subtract 4. So this one would be an arithmetic sequence. Your common difference would be d equals -4. And we could say that now minus 4 equals next. And a sub 1 would equal 55. All right, so 2 more examples. We have 2, 5, 10, and 17. So 2 to 5, we could subtract 3. Can we add 3? Can we add 3 to go from 5 to 10? No. So let's look at it again. How about to go from 5 to 10, we could multiply by 2. But can we multiply 2 times 2 to get 5? No. So this one is not working either way. So it's neither arithmetic nor geometric. So if neither way works to make this increase, which it is increasing, we just say that it doesn't fit that. It's not geometric and it's not arithmetic, so it's just neither. And we have one more example. 1, 4, 9, 16, 25, and 36. So again, we can tell this is increasing, but we want to know if it fits into an arithmetic sequence or a geometric sequence by following a common difference or a common ratio. And if not, we say neither. So 1 to 4, we could say 1 times 4 or 1 plus 3. One of those two things would have to be true. But then to go from 4 to 9, we can't multiply by 4 to get 9, so that doesn't work. Can we add 3 to go from 4 to 9? Nope, that doesn't work. So if it doesn't work to get the same difference or ratio